Traditional fuel cars rely on engine power to provide power to the steering system to assist the driver to be able to easily turn the heavy wheels. Purely electric cars do not have an engine is to rely on wind energy to provide power to the steering system. This lesson, let us take the question to learn about electric power steering system together. There are three course objectives, namely, familiarize yourself with the definition and trends of electric power steering systems. Knowledge of the types and structural components of electric power steering systems. Learn how electric power steering systems work. We will learn today's content through the following three parts. 1. Definition and development trend of electric power steering system. Definition of EPS system. Electric power steering, or EPS for short, is a power steering system that relies directly on an electric motor to provide auxiliary torque. The function is to reduce the driver's handling effort when steering and improve driving comfort and safety. Trends in EPS systems. 1. Milestones. The steering system has gone through 4 stages of development, from mechanical steering system to hydraulic power steering system, and then to electronic hydraulic power steering system and electric power steering system. 2. Vantage. 1. Improved driving comfort. The EPS system is capable of adjusting the amount of assistance in real time according to the driver's steering intentions and speed changes, making steering operations easier and more comfortable. 2. Improved fuel economy. The EPS system provides assistance only when it is needed, avoiding the waste of energy caused by the continuous operation of a traditional hydraulic power assist system. 3. Enhanced driving safety. The EPS system can improve the steering performance of the vehicle and enhance the stability and safety of the vehicle's handling in complex road conditions. 3. Growing trend. At present, EPS systems have been widely used worldwide, especially in the field of non-energy vehicles and energy-saving vehicles. With the continuous progress of technology and cost reduction, the popularity of EPS system will be further increased. 2. Types and structural components of electric power steering systems. 1. Types of EPS systems. The electric power steering system is based on the installation position of the power motor. The EPS system can be divided into 3 types: steering shaft assisted, gear assisted, and rack dash and dash pinion dash assisted. 1. Steering shaft assisted. The electric motor is fixed on one side of the steering shaft and connected to the steering shaft through a reduction mechanism to directly drive the steering shaft for power steering. 2. Gear assisted. The electric motor and reduction mechanism are connected to the pinion gear and directly drive the gear for power steering. 3. Rack and pinion assisted. The electric motor and reduction mechanism directly drive the rack to provide assistance. 2. Components of the EPS system. The electric steering assist system is mainly composed of a torque sensor, a quartering sensor, a speed sensor, an electric motor, a reduction mechanism, and an electronic control unit (ECU). These components work together to provide appropriate steering assistance based on driving conditions and driver steering inputs. 1. Angle sensor. The function is to capture the signals of steering angle and angular velocity applied to the steering wheel by the driver, which are processed and input to the ECU. 2. Torque sensor. It is used to detect the amount and direction of steering wheel torque in real time and send signals to the EPS control unit. 3. Speed sensor. Electromagnetic induction sensors are generally used, mounted on the gearbox, to detect the current driving speed of the vehicle and transmit the change in speed signals to the ECU, so as to facilitate the adjustment at the power assisting effect. 4. Electric motor. The electric motor is the power source of the EPS system, and it outputs the appropriate boost torque according to the control instructions from the ECU. When the driver turns the steering wheel, the power assisting torque generated by the electric motor will help the driver complete the steering operation more easily. 5. ECU. The ECU is the brain of the EPS system. which receives signals from the torque sensor and the speed sensor, and sends commands to the motor after processing to control the direction of rotation of the motor and the size of the booster current. The ECU is also responsible for monitoring the status of the system to ensure that the system operates normally. 6-dot electromagnetic clutch serves to connect and disconnect the motor from the steering mechanism in the EPS system. When the system needs to work, it connects the electric motor to the steering mechanism so that the electric motor can provide power assistance. When the system does not need to work, it disconnects the electric motor from the steering mechanism to save energy. 7. Reduction mechanism converts the high-speed, low-torque output of the motor to a low-speed, high-torque output to drive the steering mechanism. 3. How electric power steering works. 1. Signal detection. When the driver turns the steering wheel, the torque sensor detects the change in torque on the input shaft and converts it into an electrical signal. The speed sensor also detects the vehicle's traveling speed and converts the speed information into an electrical signal as well. 2. Signal processing. ECU receives electrical signals from the torque sensor and the vehicle's speed sensor. The ECU processes and analyzes these signals according to preset algorithms and programs to determine the direction of motor rotation and the amount of boost current. 3. Auxiliary control. The ECU controls the current and direction of rotation of the electric motor to generate the appropriate boost torque from the motor. The torque from the electric motor is transmitted to the steering system through the reduction mechanism, helping the driver to complete steering operations more easily. Without real-time adjustments, the EPS system is able to adjust the amount of power assistance in real time according to changes in vehicle speed and steering wheel torque. At low speeds, the system provides greater assistance to make steering lighter. At high speeds, the system reduces the assistance to maintain steering stability. In this course, we have studied EPS systems from 3 aspects: definition and development trends, types and structural composition, and working principles. We believe that you have gained an understanding of the entire knowledge and hope that you can consolidate the content on your own to lay a foundation for the troubleshooting of EPS systems.